Okay, so chemists, we are on to our next lesson, which is lethal dose. And I find lethal dose to be, well, obviously very morbid, but a very interesting topic. So the way we measure lethal dose, and you saw this in class, is that it's the amount of substance that kills 50% of a test sample of animals. And it is expressed in terms of milligram of substance per kilogram of body weight. All right. And this can it can help us to compare relative toxicities. So it's one thing more toxic than the other. And this is one of the reasons why I dislike biology as opposed to chemistry. It says that kills 50% of a test sample of animals. All animals are not the same. Biological systems are extremely difficult to model. And everybody, that's saying everybody's different. Everybody's bodies are different. Everybody metabolizes things slightly differently. So this would kill 50%. Certain things like acetaminophen that are in Tylenol, some people have very, very small lethal dose, or it's very toxic to some people. To other people, they can take lots and lots of it. It has to do with, like I said, your metabolism, how your body reacts with things. So, and this is expressed in milligrams of substance per kilogram of body weight, because me, as I near 200 pounds, it's going to take more of a substance to kill me than, say, like one of you guys who might be, 100, 150, whatever pounds. I'm bigger. I have more body weight. It takes more stuff to get me sick, or for it to be toxic to me. So we measure in milligrams per kilogram of body weight. This is going to, not only is it interesting, it's going to help us with the math that's coming up, which is a lot of unit conversions. So the way we do this, we can do unit cancellation method to change units. So I just made sort of a mistake in the way I spoke, at least in terms of chemistry. Cancellation. There's only one L there, so just ignore that. I want you to learn the unit cancellation method. This is one of those things that for some of you it's going to sink in immediately, and for others it's going to take a long time. That's okay, you can get there. It's a valuable skill to have, because if you're lost on a problem that involves math, if you use this method, you might be able to figure out your way around something. And it involves a lot of use of ratios. So let's use me, for example. Say I am approximately 200 pounds. I'm not quite there yet. And I want to know how many kilograms that is. How many kgs am I? So here's how I start. I start with my 200 pounds. And I use now a ratio. I know that 1 kilogram equals 2.2 pounds. Or I can rewrite this as 2.2 pounds per 1 kilogram. This is just a ratio, or 1 kilogram over 2.2 pounds. Because this number is 1 kilogram is equal to 2.2 pounds, it's the same as saying, this is the same as saying 3 over 3. Crosses out to be 1. You can multiply any number by 1 and get the same number. We're just looking at it in terms of different units. So it's like you're multiplying a number by 1 in a way. You're just changing the way that you're talking about it. So if I weigh 200 pounds, my next step is to put the ratio in. Well, this is unit cancellation, so I want to cancel out units. So if I had something like 4x, and I wanted to know how many y it was, and I knew that x equals 2y, well, I would put the x on the bottom so it can cancel out, and the 2y on the top, so that would be equal to 8y. So in this case, I have 2.2 pounds per 1 kilogram. And Mr. Gagne just came in to join me as I'm going through this lecture. So now I can cross out the pounds, and I get 200 over 2.2, and I can bring my units over. I could probably do that in my head, but I don't want to mess it up. So I will do 200 divided by 2.2 on my calculator, and I will get I weigh approximately 90.9 kilograms. So see how I did that there? I took the unit that I wanted to get rid of, put it on the bottom so it can cancel out. The unit I wanted on top, so that's what I'm left behind with. So doing a problem like that, you can go through, and we did it in class too. Okay, so everything is toxic. Toxicity depends on two quantities: the amount of toxic substance and mass / body weight of the organism. All substances are toxic in large enough doses. Since I'm doing this before class, I don't know exactly what we're going to talk about, but I would imagine we'll talk about water and how water is toxic. You can get super hydrated, and the cells in your body burst because of the concentration gradient. So that's a terrible way to die. It happened in like 5 or 10 years ago. It happened to a game show contestant for a radio show. They had to drink a certain amount of water in a certain amount of time, and ended up killing the woman. So that's bad. Sugar, definitely, you can have too much sugar, it will kill you. So anything is toxic in large enough doses. So LD50 measures toxicity. And low LD50 equals more toxic. Right, so the smaller amount per mass it takes to kill you, the more toxic it is. But beware units, because there are things that measure toxicity in nanograms per kilogram, milligrams, or grams. So which is more toxic? One that is 10 grams per kilogram or 600 nanograms per kilogram? Which is more toxic? Well, this one's much more toxic. The 600 is bigger, but nanograms, 1 nanogram equals 1 times 10 to the minus 9th grams. So just beware of the units that you're using. Okay, so I should have put this up front, but I want you to copy this into your notebook, because this is, like I said, this is a method that's very valuable. So unit cancellation, you're going to write your starting quantity, including units. So in my case, that was the 200 pounds. Write a conversion factor, where you place the units you want to cancel on bottom, and the units you want to get on top. So for me, that was, I'll just write it in here. You don't need to write this in, but just so you know as I'm going through, 200 pounds. Put the units you want to cancel on the bottom, so that was pounds. The units you want on top, kilogram. And multiply the numbers on the top and divide by the numbers on the bottom, and I get 90.9 kilograms. All right. So pause here, copy this down. We'll practice this, but this is going to be valuable as we move forward in this unit and for the rest of chemistry. So we'll do one example where convert 55 miles per hour to kilograms per hour. So step 1, write down. So this one is going to be miles per hour. So I start with that. Well, I need a conversion factor from kilograms to miles. So I know I want, kilometers to miles. I need kilometers to miles. So I'm just going to, I know this from running cross country, that 1.6 kilometers is equal to 1 mile. Oh, that should be MI, or lest you think it's meters. 55 meters per hour would be very, very slow. Okay, so I put 1 mile on the bottom, 1.6 kilometers on top. The miles cross out. Remember, just like if I had an X here and an X here, those X's cross out. Same is true for units. So I get 55 times 1.6 over 1. So I get about 88 kilometers per hour. So here was my ratio. Here was my starting point. And here was my answer. And I'm happy to do this with you in XBlocks because I think it's just a valuable skill to have. All right, wrap up. How much is too much of a substance? Toxicity is relative to dosage. This is also true of therapeutic effects. We've been talking about toxicity, but also like the drugs that you may take, antibiotics or asthma drugs or ibuprofen, painkillers. The toxicity, or in this case, the therapeutic effect of a substance depends on the dose. If you take ibuprofen, maybe you take 1, and that's good for you. Maybe you take 2, depending on your size. If you take half of 1, it probably is not going to work. That's the therapeutic effect, or the therapeutic dose. Similar to toxicity, although the therapeutic effect is much lower. The problem with a lot of drugs comes that the therapeutic effect also is toxic. So a lot of chemotherapeutics, drugs for cancer, are very toxic. So you're weighing the gains you're getting, the therapy, versus the toxicity. So the lethal dose of a substance is often expressed as a ratio between mass of the substance and 1 kilogram of body mass of the organism. So we are assuming that something that's toxic in 1 kilogram of rat would be similarly toxic in 1 kilogram of human. That's not always true. There are things, I did one study once that was perfectly fine in rats, and then it got to monkeys and was super toxic. So that product sort of ended its life cycle there. But other things, if they're fine in rats or mice, fine in monkeys, then they'll be tested in humans.